So we are going to model another component of the V block, and specifically we're going to model the shoe that goes across the V block itself that helps grip the sort of metal bars that we put in place. It's a sort of horseshoe shaped design, and we're going to start this by drawing it on the sort of end elevation standpoint just here. I'm going to create a new sketch. Now the shape itself is horseshoe shaped nature, so it requires two circles. So I'm going to start with one circle, and the drawing says it's got an outside radius of 40 millimeters, which means we need to draw an 80 millimeter diameter circle. The inside radius is 30 millimeters, so obviously means a 60 millimeter diameter circle. I'm going to take a straight line tool and turn this for construction and draw this through the center, and then use the trim tool to trim away half the circle. So we're left with a semicircle arch shape there. I'm now going to draw one leg of the horseshoe shape of this shoe that attaches to the V block. And I'm going to take the straight line tool, turn off the construction mode. I'm going to start from the outside. I'm going to draw straight down, and the overall height of this component is 35 millimeters. It then comes in a further 15 millimeters going by the drawing. It's then up 15 millimeters. It's in 5 millimeters, and then we're back to the beginning. And this feature itself has 3 chamfers put onto it, so it's got one at each of these corners because it's a metal product. And I'm going to take the chamfer tool, and the chamfers are all 2 millimeters by 45 degrees. So Inventor here will default things to 45 degrees. We just had to set the distance. I'm going to click on this corner, and this corner here. Good, so I'm happy with that. I'm now going to mirror that on a line of symmetry across to the other side. So I'm going to take the straight line tool and put this up through the middle. And then I'm going to take the mirror command and, holding down the shift key, select the lines or edges that I'm wanting to mirror. Then choose the mirror line, select that center point and say apply, and we've got it onto the other side just there. Excellent. So I'm finished with that sketch now, and I want to extrude this, and the size according to the drawing is 20 millimeters. Now again, I could extrude it just 20 millimeters out on this plane, from the plane in this direction, or I can make it go the other direction. But I do know, according to the drawing, that I'm needing to put a boss with a hole through it, which is threaded through the center. So the best thing to do is to use the work plane I've been previously using. So to get it in the center then, if I just use the symmetric option, that's in the middle there, and I can say OK. Right, I'm now going to go back to that plane, create a new sketch. Now this sketch is half inside the current 3D model. So if I was to draw anything, just say I drew a line just here, I can't see it. It's inside the 3D model. If I hit F7 or function 7 on my keyboard, it gives you a sectional view. It cuts the 3D model in half so I can see inside what I'm drawing, which is exactly what I'm needing to do. But I don't need that line. What I do need is to find the sort of midpoint between these two arcs, these semicircles. So to do that, I'm going to take project geometry for construction, and I'm going to grab one of these edges, and the computer will draw it then as a line. It has just drawn that as a faint dashed yellow line there. I'm going to take the offset tool and offset this in 5 millimeters. So we've now found the midpoint between the two semicircles. I'm going to take a 2-point center rectangle now, but not for construction. I'm then going to bring this up. Now, according to the drawing, the height of this component is 14 millimeters tall, and the outside diameter is 10 millimeters, so I can just draw it like that. But because I'm going to use the revolve tool, I only want half of this, so I'm going to take the straight line and put that down the middle. I'm going to finish that sketch, take the revolve tool and put my mouse very carefully over the profile. You could accidentally select both of these by mistake, but I'm just going to put it over one side. Select the axis as that middle line that I just drew, and it will draw me in my boss component. Say OK. Okay, only two more little things to do. We've got to put a hole through this and then put a cosmetic thread. So I'm going to create a new sketch on this surface. The inside diameter of this is 6 millimeters, going by the size on the plan view of the drawing. Finish that and extrude that, and I'm going to say through to that face just there. So I've selected the through command to that face and I'm making sure I'm subtracting the material just there, and say OK. Okay, one final thing to do is to add what we call a cosmetic thread. You could add a real thread effect by using the helix or coil command and 3D model a real thread in this. But the issue is it's going to create lots of extra vertices, it's going to create lots of extra faces, and that is going to slow down your computer dramatically. And there's not for any real advantage for it. But what we do want is to say this is a thread, and then later on when it comes to the technical drawings, be able to identify that this is a threaded component. So if I select the word thread and point to this hole, it will wrap round an image which symbolises a thread. You do get lots of different options for threads. That's not the point of this video just here, but there's lots of technical issues to do with different types of threads, different sizes, different pitches, different directions. We don't need to know that. We're just going to say OK, and we're given a cosmetic thread just there which will appear in our technical drawings, and that is that component ready.